Hi, I'm Tyler Scripjack from Warrenwoods Tower, and this is my presentation on the physics in the Lorax. So to begin, I'm going to set the scene by showing you guys my movie clip.
Whoa!
Loser!
Oh, really?
Oh no!
Hey!
The seed!
Get that seed! Hang on! Here we go! Grammy!
Seriously? How cool is your grandma?
No! Come on!
Yeah, that's right.
There it is! Hey! Watch the road, you meathead! Hey! Ow! Oh, come on! What the? Get it unstuck! Get it unstuck! Bring it on, Teddy! You don't have the guts!
Ted!
Grammy! Hey!
Hey, it's Mr. Lorax!
Take that, shorty!
So for my clip, the specific concept that I'll be focusing on is terminal velocity. Terminal velocity is defined as the constant speed that a freely falling object eventually reaches when the resistance of the medium through which it is falling prevents further acceleration. And it is found using this equation, which will be further explained later. Next, I have some force diagrams of the seed through different stages of its fall. First, we have just gravity acting on the seed, and then the drag force begins to act on it as it falls, and eventually the drag force will completely counteract the gravity, and the net force will be zero, and it is at that point which it reaches terminal velocity. Now, using these force diagrams, we can determine an equation for the net force, which will be the force of gravity minus the drag force as they're moving in opposite directions. And then, using this, we know that at terminal velocity, the net force will be zero, and we found the equation for drag force, which I found on Google, which is half times the density of the fluid it is traveling through, times the terminal velocity squared, times the drag coefficient, times the area of the object. And then because the net force is zero, we have that gravity minus the drag force is equal to zero, and using algebra we can find that gravity will be equivalent to the drag force. Now, solving this equation for the terminal velocity, we have that terminal velocity is equivalent to the square root of 2 mg over the density of the fluid times the area of the object times the drag coefficient. Now for the values we need, first the mass, which I found by finding the tree the Truffula tree was based on and finding the mass of one of its seeds, gravity, which is 9.8 meters per second squared, and then the estimated radius of the seed, which is 0.021, also found using the previously mentioned tree, which then I multiplied by pi and squared it to find the surface area. The density of the fluid, which I used pure oxygen because Mr. O'Hare definitely gave him the good oxygen in his bottled air. And lastly, the drag coefficient, which I found a study that found the drag coefficients of multiple seeds. Now, to solve for the terminal velocity, first all the numbers are plugged in, and then we are given a result of 0.312 meters per second, which I believe is reasonable because that seed is falling very slow. Lastly, we have the questions that can be answered. What is terminal velocity? Terminal velocity is the max speed that can be reached by a free-falling object with a force acting against it. And what values are required to solve for it would be mass, gravity, terminal velocity, the density of the fluid, and the area of the object, along with the drag coefficient. Alright, and here's my works cited. Thank you for watching. Any questions?